Hi, and welcome to today's little quickie. In today's little quickie, we're going to be doing two things. First thing is we're going to be looking at how to separate a MT3 J33 mandrel from a drill chuck, how to separate them. And the second thing is, well, I have a problem. Actually, I have several problems, but the judge said that as long as I keep it up with my medications, and as long as I don't mingle with the general population, well, then I can stay outside a little longer. But my problem here is that this little drill chuck is broken. If we come in really closely here and take a look, we'll see, and here's a picture of it, that there is a very clean stress crack all along the body of the crown gear of this drill chuck. And that obviously is a problem, because when I tighten the crown gear down, well, the drill chuck just spins freely. So I'm going to have to repair that. But before I do that, I'm going to have to disassemble the drill chuck from its arbor. And before we look at doing that with this small and very delicate drill chuck, we're going to set it aside. And we'll take a look at how to do it with something a little more massive. I have here pretty well everything that I need to do the job. I have a couple of washers that I've opened up, and I have a couple of wedges, a hammer handle wedge and an axe handle wedge. I have a small hard tipped hammer, and obviously I have my drill chuck and the mandrel that I have to remove. Now that went well, and it really isn't much more of a problem than that. Now, I am a cheap kind of guy, so I made do with things that I could find around the shop. But you can get wedge washers that are specifically made to do the job. And instead of hitting on wedges to separate the mandrel from the chuck, well, you can just put the washers side per side, insert into a good bench vise, and tighten the vise down to squeeze those tapered washers together and separate the chuck that way. Regardless of how you plan or decide to do it, the expensive way or the down and dirty way, one thing is sure: you want to ensure that your mandrel, once separated, doesn't fly off and hit the concrete floor. That's why I was aiming towards the back here on my wooden workbench to avoid all damage to the mandrel. So let's set this aside and bring in our second contestant, which is this very small and delicate drill chuck. And this we're going to have to approach in a whole different manner. The problem with this small drill chuck, since that it's a drill chuck that's made to produce small holes and to be manually fed into the part, is that its mandrel is very delicate. And we have a bearing here that's going to cause me a problem, because if I use a wedge to separate the chuck from the mandrel, well, I'm going to definitely damage the bearings and the assembly here of that mandrel. So what am I going to do? Well, the back here of the drill chuck is quite rigid, and I can use that, and they've done something here that not all chucks have, and very little have actually, and that's they've produced a hole down in the bottom of this chuck here. And that hole can be used to drive the mandrel off of the drill chuck. But for that I'm going to have to support it in some way. Now what I'm going to use here is something relatively soft but still quite rigid, and I'm going to use this aluminum roofing nail that I'm going to insert snug down. Now it's snug, I'm just going to loosen it a little bit so that it stays mobile but that it's aligned with the hole at the bottom. Now I have to support that, and that's what this is going to be used for. I can hold this in the vise and come and support it and then tap that mandrel right out by using a crisp hit on that softish nail. So let's take a look at that. Well, that went really well, but that was the easy part. Now I have to fix the drill chuck. Well, this little quickie might have just gotten a little longer because I had one of those what if moments. And the what if moment that I had was, well, what if there was a hole in the bottom of this much larger drill chuck, just like there was a hole in the bottom of this tiny drill chuck? So why don't I just go and try and drill a hole and see? But not only drill a hole, the second what if that came to mind was, what if I used a drill tap size, a 5/16, for tapping a 3/8/16 hole? I might then be able to use a 3/8/16, a good quality socket head cap screw, as a puller and not have to use wedges and all that stuff at all. Just use a regular 3/8/16 screw to act as a puller through that 3/8/16 tapped hole. Well, that sounds great, but first things first, let's see if we can actually drill a 5/16 hole in the bottom of this drill chuck. So here we are at my small Atlas lathe. We're going to be holding this 3-jaw drill chuck into this 3-jaw lathe chuck. And we're going to be holding it so that the front end of the drill chuck protrudes in this direction towards the tailstock of the lathe. And that means that we're going to be drilling into this side. And I want to do that because the rotation of the machine that's going to be counterclockwise, and the fact that the drill cuts in a clockwise direction, well, that'll force my drill chuck open, and that will guarantee that the drill chuck doesn't close down or grab onto my drill as I'm cutting, because that would really make a mess. So let's install our drill chuck in the 3-jaw chuck. Okay, so we're installed here. And please note, especially for the novice machinists out there, that I've installed the part into the 3-jaw chuck before installing the drill bit in the drill chuck of the tailstock here. And that is because I'll be able to move more freely here without grabbing onto that sharp tool that could cut me. So always install, whenever possible, your tooling at the very last moment. So my drill chuck is installed in the 3-jaw chuck. Now let's install our 5/16 drill bit. Let's cut. Well, that went really well. I have my drilled and tapped 3/8/16 hole that goes all the way through here that I can use, I hope, to help with a puller to separate the mandrel from the chuck. Now, before I go any further, I'll have to assemble both. So I have already cleaned both tapers and we can assemble them.
To avoid damaging the tool, use the brass tip of the hammer.
Now that we have our chuck and mandrel assembled, well, we need some kind of drive screw. And here I have a 3/8/16 Umbraco socket head cap screw, this top quality screw, because I don't want to take any chances here and break a screw into that hole as I torque it down. But I also want to be able to remove the screw after I've used it, and I have to be wary of mushrooming the end of the screw. I'm going to be applying a fair bit of pressure here. So I've modified the end of the screw so that any mushrooming that might occur won't impede me from retracting that screw from the hole. And I'm also going to help myself out by reducing the friction. I'm going to just lightly oil the screw, and that'll just help me because it will require less torque to do the same work. That worked very well. I'm surprised that I haven't seen this before on drill chucks. The only downside that I can see here is that if a drill bit were to be pushed up into the chuck, and if the drill had the right size, well, it could come and lean up onto those threads in the hole and damage them. But that could be easily avoided just by using a simple threaded plug with a very thin head on it. And it would stop the drill from coming in contact with those threads. Now, you wouldn't have to worry though that the drill would go through the hole by pushing up into the drill chuck and separate the drill chuck from the arbor. I mean, the force isn't going in the right direction for that to happen. Now, I've never seen this on other drill chucks, but maybe it does exist already. If it doesn't, well, then it's an original lazy machinist idea. And if it is, Mr. or Mrs. Jacobs from the Jacobs Chuck Company, well, if you want to use this idea, feel free to do so. I don't need any money. But there are a few, or at least 2 soup kitchens and 1 home for handicapped people near my place that could really use a helping hand money-wise. So if you think this is a good idea, and it is original, I don't know if it is, but if it is, well, we can talk. Maybe we can use this idea to help others. Now, we have to get back to our video, and we were at the point in this little quickie video where we were going to start to look at repairing this broken, small but very cute number 0 Jacobs drill chuck. Well, so much for continuity. We were at the point where we wanted to look at fixing this number 0 drill chuck because it had a very nice stress crack. Nice because it's very straight, almost looks like it was put there purposely, but a very nice stress crack along the outside sleeve, the one that has the crown drive gear on it. And to fix that, well, we have some options. Now, a reasonable man would maybe remove this sleeve. It's just press fit on there. It can be pressed off quite readily. And then buy a new one. Or an even more reasonable man would probably just put the whole chuck in a box and send it off to the Jacobs Company to be repaired. But I am not a reasonable man, so what am I going to do? Well, I'm going to do something that's a little more fun than putting it in a box and sending it away. And no, we're not going to TIG weld it back together. This won't be an accurate way of fixing this delicate part. What we're going to do is we're going to produce a small ring. A ring that will be a light press fit on this outer sleeve, and I'm going to press fit it onto this sleeve, compressing it back to its original diameter. And since the sleeve that I'm going to produce is going to be made from this piece of tool steel, this is O1 steel, O for oil and 1 for class 1, which is tool steel. So oil quenching tool steel. Now I'm going to make a ring out of this tool steel, but I'm not going to harden it because you don't want to press fit something hard onto something hard. I'm going to leave it soft, but even in its soft state, this tool steel is tough stuff. I mean, this is very strong in tension or tensile strength, and it'll make a really nice strong ring to compress the sleeve back to its position and hold it there. And if I do this nicely, I mean, I make a pretty ring, well, people won't even know that it's a repair. So let's take a look at that.
that I've changed the direction of rotation. I'm turning clockwise because I'm going to be deburring the inside of the hole. Safety alert! I am only polishing the edge and the end of the part. Never stick your finger in a part to polish the inside with emery cloth. Never, never stick your finger inside a part.
So here we have our broken drill chuck, and we have the ring that we've produced to try and repair it. Now all we have to do is press fit the ring over the sleeve here and everything should be just fine. However, I'm going to press fit this in my vise, and I don't want to be pushing up against these delicate jaws here. So I'm going to use something so that I can push directly onto what needs to be supported here, and that's the sleeve, because if I didn't support it, well, I'd be press fitting it off. So that will be fine, but I still have a problem here, and that is that I have to protect this against the jaw. So I'm going to use this little piece of brass here just to protect that. So now I have my chuck and the ring partially press fit on there, but I still have a ways to go. I would like to bring the ring up to about the start of the lettering on the chuck sleeve here. So what am I going to do? Well, I'm going to support the end again, because if I'm going to be pushing up against the sleeve, well, I want it to stay on. But this time I'm also going to use a socket on the back end so that I can push it up onto the body a little further. I'm just going to turn it so I can see my lettering here and start clamping it down. Well, there you go. Looks pretty darn good. Talking about the chuck here. The repair went well, didn't cost anything except for a little time, but that's okay because I had fun. And isn't that what a home shop is supposed to be all about? Having fun? And this was great fun. So the little quickie was a little long. Deal with it. What can I say? Until we meet again, have fun, be safe, and happy machining.